So we're going to take a look at kinematics today. And the big idea of what we're looking at is that the interaction of an object with objects can be described by forces. So we're going to take a look at how to do these forces affect our object. Our object is Janice. So we're going to be working with Janice. She was named by last year's AP class, and she's going to be very important to what we do today. So, kinematics, if I had to give it a definition, is describing motion with equations and graphs. So equations and graphs is going to be huge with what we're looking at over the next couple of weeks. So, if I were to take Janice and put her on our track and not move her, just leave her there, she becomes a motionless ball. So that's going to be our first example. So the first thing that you want to do in anything that you're trying to tackle in physics is draw a diagram. So I'm going to draw Janice on our track. So here's our track. Here's Janice. And in order for us to describe her position, we need to assign numbers to where this track is. So we're going to assign this as x plus, and this. Okay, so let's try that again. Draw. Okay. This is going to be time on the x-axis and position on the y. So if I take a look, I can assign this as time 0 and this as position 0 for our purposes right now. So how do I plot Janice, the motionless ball? Well, again, like I said, if we look, she's at 81 centimeters. So we're going to mark 81 centimeters on our graph. Well, what happens over time? Let's take a look. If we were to mark time 1, time 2, time 3, well, let's check. Oh, she's at 81 centimeters. Oh, she's still at 81 centimeters. Oh, yep, still at 81 centimeters. So if I were to plot that, she's just staying at 81 centimeters. She's a motionless ball, and any motionless object is going to have a position time graph that looks like this. So make sure you write that down. It's a position time graph. For a motionless object. Now let's quickly look at the equation for a motionless ball. What do we know? We know the position, which is x, and it's a function of time, but we're not going to write it as how you're used to with a function of time. We're going to leave it like this because I don't want you to get confused and think you're multiplying by time. And we know that Janice is at 81 centimeters. So her position equals 81 centimeters. And in this case, this is constant. It's not changing, and no matter how much time changed, this remains constant. So this is something what your equation would look like for a motionless ball.